Okay, so today we're going to learn about another important special case called a perfect square trinomial. Now first, remember that perfect square is a term that you already know. As a quick review, over here on the left, if we use this kind of generic grid, if I want to shade in a perfect square of 9, that means that I'm going to shade in a square or draw a square that has an area of 9, but that has here sides of 3 and 3. So this is an example of a visual of 9 being a perfect square. Let's say 3 by 3 square. Remember that the side lengths are the square roots of this perfect square. So we know this term perfect square. We can recognize when we have them. And we also know the term trinomial. The term trinomial means 3 terms. So if you think about these terms on their own, we know what they mean. So putting it together, the goal for today is to recognize when do we have a perfect square trinomial. And guys, to start, we're going to first look at example A. Do you remember when we had this binomial before, x plus 3 quantity squared, and we can multiply it out using the box method? So let's try that real quick. So we'll draw a box, and it's going to be x plus 3 times x plus 3. Because if I go through this, x times x is x squared. And then x times 3 is 3x. Down here, 3 times x is 3x. And then 3 times 3 will be 9. Guys, if you look at this box method, notice that now we can combine like terms. So here we can add these two 3x's together. So 3x plus 3x will give us here 6x. And then we're left with this x squared out in front, and then a plus 9 here at the back. So here we've multiplied together x plus 3 times x plus 3 to give us a result of x squared plus 6x plus 9. Well guys, in this example, if you look carefully, here are some observations. First, notice how our first term here, x squared, this is a perfect square. So here, this is a perfect square here. This is a perfect square. In addition, do you see how we have this 9 here on the back? Guys, 9 also is a perfect square. And then if you look at the result, notice that it has 3 terms, 1, 2, 3. So this is an example of what you're going to learn to recognize today of what we call a perfect square trinomial. Basically, you're going to have a perfect square for the first term, a perfect square for the third term, and the center term, our b value, this is going to be double, a double value. So in other words, I'll show you the picture here. So here, notice how we have a repeated 3x plus 3x. So I'll show you once we go over the note that you recognize how to identify this middle term to verify that this actually works out to be this special case. We'll try one more example here. So in example B, we're going to multiply x plus 7 quantity squared. Again, this is just a square with sides of x plus 7. Do you see? They have the exact same side lengths, so it's still going to be a square. But for this activity, we're going to use the box method and multiply. X times x is x squared. Here's a perfect square. If I jump down here to the bottom, 7 times 7 is 49. So this is another perfect square. And if you catch on to this pattern, here, x times 7 is 7x. I'll use it in blue here so you can see it different. And then 7 times x is 7x. So do you see this happening each time now? When I look at the result, I have a perfect square, so x squared. And then I'm going to end up having this repeated middle term that's a like term, so 7x plus 7x will be 14x. And then this back term here, 49, is also a perfect square. So this here is also called a perfect square trinomial. Again, the first term is a perfect square, so is the last term. And then this center term will be double of the, you'll see in a second with the notes. So with that, guys, this is an example of how we look at it from multiplying from the square root back into the perfect square trinomial. And then in a second, we'll look at the general form and identify the actual pattern using the textbook language.